because people then, when they start looking at, you have a lot of processes and you send messages between them, how do you design with this? Because people, they are just coming in, I know object orientation and I know nothing more, and sending a message is just weird. And then you need to explain these things to them. And then you also need to go into error handling and things along that. And then you also need to go into testing, because I wrote this code and of course it had a deadlock in it. It's the first deadlock I've ever created, but I also made the design so clumsy that it had to come there. But it also is because of experimenting with things. So I've trimmed down these slides and trying to just to give you the highlight of what the design is. And then I'm highlighting a few issues, or not issues, a few ways I'm using mocking to test this design I've created. And then I have some open ends that I hope we can discuss there, and I'm trying to lead it in so that I'm not talking for a full hour. I'm not planned on that. I hope that we can then look at what have you done here, can we improve this, and see if we can learn from this there. Live hacking. It's live hacking, yeah, hacking the game of life. Yes, so good. So, and all of this comes to what I think these are the two books you need to read on these things. CSP, there's no excuse. It's free online, and it's actually legally free online. The other one is also online, but that's not legally free because it's Springer and it has to cost $110 to get it. But it's actually a very good book about how you design protocols, all the different issues that goes into that. And it uses CSP as an underlying formalism. And that's actually what I grew up on before I saw Erlang. And then when I saw Erlang, my brain just, this works there. So that's, and you can see you have things like, again, if you're doing things with protocols, you have paxos here, evidently it has to be hard to write and make it look at, because you use text-based things to describe the protocols, but there you go. So anyway, you know Game of Life, it's a simple cellular automaton. You have the evolution of cells and you have discrete time. Everybody know the problem? Good, so here you have one cell here in the middle, and it evolves depending on the neighboring cells. Those 8 ones there. If it has 2 or 3 neighbors, it survives to the next generation. If it's empty and there are 3 neighbors, a new cell will emerge there, and all others, they'll just go empty. So you can get these nice patterns and they evolve over time. So I actually did one by hand. So I have here, and the thing here is, this is like a globe, so it wraps around the board and also at the sides. There, I thought that was seemed to be a cool thing to do. And then over time, it will evolve like this. And trust me, I tried to do this by hand, and then I just wrote the program for it and then did these slides afterwards, because you can't do this by hand. It's just, it's simple rules, but you can't figure it out there. So you can see how it evolves over time. And you're going here, this is actually going really, really well, this thing. And funnily enough, this lasts 17 generations and then it dies out. But that's for Game of Life Feinschmeckers. They will have a great fun looking at different patterns and how they survive there. So the traditional approach, if you're doing this in anything but Erlang, is you write up a 2D array. You have one generation in one array, they have a new array that's empty, and then you just iterate over it and compute the new ones. And then you can't do that in Erlang, of course. You do not want to write an array in Erlang. It's just, come on. Yeah. You do a list instead. You do a list instead there. No, so the basic Erlang idea, of course, is that you have one process per cell. That's just how you have to go and do it. And then you talk to neighboring cells. And this is one of the things I'm doing when I've been touring around and explaining Erlang. You take a problem that people know, and you solve it how you do it in Erlang. Because then you don't, and now I'm doing this nifty protocol, and people go, I don't know the protocol, and they've just lost them there. Game of Life, everybody knows. This one, when I present it there, people go, oh, but Game of Life, blah, 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 and you have people coming, and they go berserk on Twitter and everything, because they understand the problem, and then they can understand the ideas. And then you tell them, these ideas, you can just go apply them when you solve your problem. And they go, so it's putting a level playing ground. So when you need to upgrade, so you have the cell here, one here, it has 8 neighbors, and I've limited down to, I think you can imagine there's more there. So you say, get the content of your one neighbor, it'll reply back with a new message, the cell content. You'll get for all 8 of them there, and when you've collected from the status of your neighbors, from all 8 neighbors, you can calculate what the next value for you should be. Very straightforward there. And then the question comes up here, and this is where we're going to do stuff that puts us a little closer to real life, but you shouldn't do this with game of life, I think. But is this Erlang enough? And of course the answer when you put a slide like this is no, 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 no. We need more processes. So, yeah, but that's how you do it, right? You put in another process. So here you can see the cell, whenever it wants to evolve one step in its life, it spawns off a collector process. And that actually, to a certain extent, makes sense, because what is the job of the collector? It's to ask all the neighbors and wait for replies. It's a very separate task it needs to do. Just do that, and when you're done, tell me back. So that actually makes sense. And you have a lot of, in real life, you will have situations like this, that if I clutter my main thing with this, it gets ugly, but you can sort of separate it out to a little process that has a nice little job. It does that and it reports back, and then it dies off again. So that's... So
what is the consequence of not doing that, if you just keep that in your main cell?
It means the code over here gets slightly more convoluted. Because then apart from answering other cells, or others that are asking you for your value, you also need to keep track of this collection of responses from your neighbors. And it's easier. That piece of code is just a separate lot of ugly state data to keep track of that separate process there. And the code I have is somewhat ugly. Some other people, they took this code and said, this is awesome. They made a distributed Erlang game of life, where they actually also separated this collector process out into its own little gen server. So they went all in on this and just made a fully distributed version of it there. They haven't quick-checked that one.
Isn't it also because you want a fault tolerance, and if one of the other neighbors dies,
yeah, that also
you want to do it in an easy way?
That's also a thing, because it actually turns out that that's one where actually when you say this is actually the way to do it, because here, if one of your neighbors dies off, then the error handling, you can handle it here, which means that error handling is not over here. It's about how you separate things. It might be overkill, it might not be, but it shows how you could also do these things in real life systems anyway. So the collector loop, that process is actually very simple. If it ends up that it's waiting for no more neighbors to come back, so that's a list here, then you send back to the cell that spawned it. Next content should be, and then you actually compute it here, what the next content of the cell should be. So then you're done. In all other cases, you're waiting on something, and then you get a receive in here, where I say, if you get cell content from someone at a certain point in time, we'll go into that in a few seconds, and if it's one of those you're waiting on, then you remove it from the list of things you're waiting on, and you add whatever count was in that neighbor. That's 0 or 1. The neighbor content is 0 or 1, and then you add it to your current count, and then you just loop until you're done. And if you get a message in you were not expecting, you just throw it away. People could be sending you garbage, and you just get out of that. Then the question, of course, is, will this work? And you can think about that for a few seconds. So you have a big array of cells, or 2D array of processes here. They're sending messages off to one another. They're spawning collector processes, and messages are going all over the place. Will this work? Of course, the answer is no. It will not work. But it works. It works if you only take one step at a time. If you tell all the cells, do a step, then it works. I haven't been able to synchronize that. Do a step now, and then with the way the Erlang schedule, I think you can find cases with Quickcheck where you can break this one, but in practical life, it hasn't happened yet. And I've used it on really, really big, like 300 by 300 fields of this there. But if you let the cells run freely, they get out of sync. And that means you start requesting old time. So you're asking a neighbor for something where he's moved on. Or you get a neighbor asking you for what's your value in the future. Because this will happen with a lot of processes. They will get out of sync. So you need to deal with it. And how you fix this is, if you get somebody asking for what happened in your past, you just keep your history. That's simple. You keep a history of what the values were in this cell over time. So you can always reply if somebody asks for an old value. And if somebody asks for something in the future, of course you just queue the response. And this is where I thought this was a cool example to use for teaching people something about, because this is a typical thing you end up doing a lot of Erlang systems. Sometimes you need to have a little bit of caching stuff so you can reply back with things, or sometimes you need to say, I can't answer you right now, so you queue the response and then you wait for it. So it's got something there that, and then you want to also supervise these things there. And then the trick here is you need to teach people what supervision means in Erlang. And that means that when you start it, you restart it with the original arguments. So you need to make sure that, and then you get this thing, all state and history is lost when you restart. We all know that. So, but for newcomers there, and the fix to this, of course, is you monitor all cells, because then you know what's going down there. And then when they've died, you step them forward to the current time in the evolution of the whole farm of cells. Again, something that will also happen in a lot of real systems. Something happens, you bring them up to speed in some way. And you can do that because you're using monitoring there. And then you end up with a supervision diagram like this. You have the top level one, you have a supervisor for all the cells, they're down here. And then you have a cell manager that are monitoring all the cells. And whenever something goes bad, one of these dies, you have a pacer that will then tell the cell, you need to go forward like this to get up to speed. And that means you can have this big 300 by 300 one, you pick out one cell, you kill it, and then you'll just see how it gets back into sync with the rest of them. There. And that's actually pretty nice, this power of just killing something and then it comes back. And the way it looks here, again, this is from the books, especially the protocol design book. They really advocate doing MSCs. And I saw an MSC in your office, Thomas, this morning. So this is what you have to do when you're doing serious stuff. If you're not writing down MSCs, you're not doing real software. Then do some JavaScript, come on. There. So here we have the cell, it's going down. The cell manager is then doing a little bit of an wait for that cell to be restarted, because when the cell supervisor restarts the cell, it actually registers again here, and then it starts monitoring it, and then it starts a pacer thing that will go and figure out what's the global max time here. What is the first one of the cells has advanced, and then you just tell that new cell, run until you reach that max time. And I can see that the Quickcheck people are really, there are lots of things we can test here. And trust me, there is there. And then there's a deadlock. There's actually a deadlock in this code here. And here, you're asking the neighbor for something in its future. You're asking for a future value. It queues you because it can't answer you until it reaches that point in its evolution. Then it dies, and it kept that queue in its state, because that's the only thing you can build that up over time. You can't do anything else. So that means this one dies, and then this guy will never get that back, even if the cell restarts. And actually, if that moves on to that point in time, it will never get that back, and it'll just be sitting there. I'm never getting that content back there. So that's, and of course, when I looked at this, I hadn't done any Quickcheck at that point. I looked at this and said, this is a prime candidate for Quickcheck. I know how to fix it in 5 minutes, but now I'll spend 3 days writing a Quickcheck thing for it instead. But again, it's to educate people. So it's okay to do that, but you can instantly fix this. It's a 5-minute thing. You look at this and you realize this, okay, no problem, especially when we have these diagrams. You sit there, oh, if this guy dies, okay, then this is happening. So it's easy to fix. But then I thought this is good for Quickcheck there. So Quickcheck, of course, and you do it operation by operation. Of course, so this leads us into mocking. And you have to look at the MSC. Just go through the MSC step by step there. And then the testing tricks here. You need the mocking in EQC. Wonderful feature. I wonder where you got the idea, Thomas. Yeah. So, and the user requirement for it. So, and then you have the problem is you cannot call a module under test. So if you have the cell here, you're asking another cell process. You can't do that because you can't mock that call there. So you had a protocol module. I'll show you how that runs. And sometimes you actually need to sync. I'm trying to do these designs every time as asynchronously as possible, but sometimes, especially for testing, you need to sync. And I'll show you some of the problems with that. So the protocol module here, that actually has these two, query content and query response. those are things that are in the equals cell module that we're trying to test. But since we're calling another instance of this one, just another process running this module, you can't mock this thing. So you need to put that protocol part into a separate module, because then you can mock it and then you can control it there. And that's just to allow mocking. And I think that's an important thing to talk to people about when you're doing these things, because otherwise they'll sit there and they go totally haywire. And then you need to sync with the collector process, because that's a little nasty bastard we're spawning off in there. And then you have this thing where you have in the collector loop, that's the process we saw before, we have a status, and in this case it just, what's the status it replies with? Yeah, can't even remember. Something, I put some sensible data in there so you can use it for debugging as well. But this you need to make sure that this process has been started in the testing. Because if this process has not been started, it has not sent out all the requests to the neighbors. And then you can't do mocking on the fact that you asked all the neighbors in it. So there's a sync here. Anybody that can fix this better, please, there. But then if you want to do a step advanced...
So what you want to do is you want to spawn that process,
yeah.
make sure all the messages go out to the neighbors,
yeah.
and from there on you want to do the mocking.
Yeah.
Okay.
So that's what we do here. And then here I'm await collecting status. So I keep asking the cell if its collecting status process has entered a state where it can reply to things, because it'll only do a receive after it's sent out the request to all the other ones. And the thing that happens with this is that in some cases the process will be spawned and it will execute something, but in most cases it will not even be spawned, and you just continue in the quick check test and you will not see those messages going out because they just come slightly out of whack here. So that's one of these things. And then you have this ugly timer sleep and things like that. But I had to do that. The more time thing sleeps we can remove from the code, the better there. And then I also had some issues here there. But then I do this step callouts for time. So that is when I'm doing a step, I should call out to all my neighbors. Yeah. And you can see here, I'm expecting that I do it to a wildcard cell and then reply back to myself. I would really, really like to state exact names of each of the cells here. I've never been able to get that to work. That would be something that would be interesting, because I know exactly which of the ones I'm going to call. You can enumerate all the neighboring cells. They have a name that's an X and a Y coordinate. So it would be really nice to be able to pinpoint that these 8 are the ones I will be asking. This guy could ask 8 random ones. And it'll
replace the wildcard with a var and find the result of the path.
Let's hack that out of it, because I want to see how that. I couldn't get that to work there. But of course, some of these things has happened under extreme time pressure to do things at conferences. So I've never had the time to go back. But let's have a look at that, because I'd really like to fix this, because this one annoys me. Really there. Of course, and then we do the fun things here. We need to kill a neighbor here. And there is some ugly sleep stuff in here as well. So I take up here, and this is an operation to kill a neighbor. You have the ID of the neighbor. You look the pit up from the cell manager. The cell manager is keeping track of all the pits for all the cells. Then you have a function where you ensure death. You monitor it. And you exit it, and until you want to see the down message coming from that neighbor, you want to really make him dead before you go on. Then you start the neighbor, then you sleep a bit, and then you do a collecting status to make sure that he is up and he has started his collector process there. And then you sleep again, and then you return the pit there. And I couldn't get those timers out of there. The sleeps I couldn't get out of. So that is something where I think this half an hour after my talk here is something where we could look into that and see what am I doing wrong? What is it that I'm not putting in right to do this? Or is it just the way it is when you're doing all these asynchronous things there? And then also on the killing the neighbor here, you're expecting that if you were waiting on that neighbor, if you'd already asked for its content, there, you'd expect that you re-ask it because you're detecting it that it goes down, and then you need to ask it again. So here you're expecting, in that case, you're expecting that you query the content of the neighbor again, but if you haven't queried it, you expect nothing. So that's, yeah.
Do you link to the ones you sent this message? Does the collector link to the nodes?
It monitors them.
Monitors them, okay. But then you should get a down message. When
Yeah, yeah, and that is also in the code. I think
in your callouts, you could either wait for the down message or...
Yeah, but the down message is part of the protocol. I'm monitoring inside that, I'm monitoring it, right? So here I want to see that if it was in a state where it had already asked the neighbor that died, I want to see that it responds to that and queries the content of that cell again. I want to make sure that it follows the protocol and the error handling in the protocol. Then I cannot put the down stuff in here, because then I'm interfering with what's going on in the Erlang design. And I don't want to do that.
So you have to wait for all of those neighbors of your neighbor
Yeah.
to realize it's back up and send those messages.
Yeah.
All that happens asynchronously.
Yeah.
So then killer has to wait long enough.
Yeah.
for all that to happen.
Yeah. So there's things there. And then anything that can tune this and make it more so it's more natural, I'd really welcome, because I don't like putting in a sleep and then trying to figure out how big should that sleep be.
No.
Because we all know that the more sleeps you have in your testing code, the longer your test is going to run for. And you really don't, we want instant replies to these things. And you say, here, I added 400 milliseconds just for this one. If you do this a lot of times, your test suite will run for a very, very long time. So I'm very open to fixing this, because this is a problem that will come up again and again. The more asynchronous you do your stuff, the more you need to find the limits of how you do these things there. And then, of course, you want to fix the deadlock here. And then what you do here is that if you get a down message in there, you make sure that if it's in the neighboring refs of what you're monitoring, if it's one of those, you go down here, and then you monitor the neighbor again, and you query the content to it. So you get a new reference on the new cell that has been restarted there, and then you loop again. So the fix is super simple. That you realize that in 5 minutes, and then instead you spend 3 days doing the quick check for it, because it's actually an interesting problem. Because in this case, the problem is so simple you can figure it out. In other situations, this will not be simple to figure out, and that's why you need the quick check, and you need to do it in a setting where people can understand it there. So then that sums it up that asynchronous protocols are nasty, but this is what you need to do to scale your system there. And of course, EQC, what else is there to do? And then focus on one process. That's the important message here. Don't try to test the entire game of life. It is not worth it there, because you don't get the focus on the protocol there. And especially also if you have a thing like components in EQC, there's really no need to try and go overboard. You focus on one thing, and then you can combine the things afterwards. There. And then of course you mock the calls to all others, and it continuously is a work in process in the repo. And the code is here, and it's on the branch called testable there, and that's it.